What is motional EMF, or in other words, motional electromotive force? Here is the 3D visualization of how motional EMF works. You have a uniform magnetic field region, typically produced by an electromagnet or a permanent magnet. A conductor of length L moves perpendicular to the magnetic field lines at a certain velocity. So, what happens when the conductor moves in a magnetic field that is perpendicular to its plane and directed downwards? As we see here, the presence of the magnetic field influences the conducting electrons, causing them to change in response to the Lorentz force. In electromagnetism, we can stick to the left hand rule to understand the flow of electrons in the conductor. Due to the Lorentz force on the electron, that is F is equal to EV cross P, or in this case, when the magnetic field is perpendicular to the charges, sine theta is equal to 1, F is equal to EVB. The forces acts or causes the electrons to move to the right end of the conductor and accumulate there, leaving a net positive charge at the other end. As the result of this, an electric field E is produced inside the moving conductor. The charge accumulation at the end lasts until the force on the charge, that is, F is equal to EE from electrostatics, is equal to the Lorentz force EVB. In steady state, the electric force balances the magnetic force, that is, EE is equal to EVB, and hence E is equal to VB. The phenomena we observe here is in accordance with the Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction states that when a conductor moves through the magnetic field, the magnetic flux through the conductor changes, and this change in magnetic flux induces an EMF in the conductor. Now, let's calculate the motional EMF. From electrostatic, we know that for a conductor of length L, the potential difference across the ends of the conductor is EL. The formula for calculating the magnitude of induced EMF, E is equal to EL. In place of E, we can replace it by VB. The emotional EMF is thus equal to uh, the velocity v with which the conductor is moving multiplied by the magnetic field strength B and the length. The potential difference across the ends of the conductor is maintained as long as it continues to move in the uniform magnetic field. When it stops to move, no motional EMF is developed. Now, let us make this moving conductor the part of a closed circuit as shown in this 3D. When this moving conductor is part of a closed circuit, the force induces a current to flow through the circuit. The induced current can be calculated using Ohm's law. I is equal to VR. Here, V is nothing but the motional EMF. I is equal to motional EMF divided by R, where R is the resistance of the circuit, which can be calculated from the multimeter. Can you now predict the direction of the current? Yes. Using the Fleming's right hand rule, we can determine the direction of the current, and the current here flows in the anti clockwise direction. In summary, motional EMF occurs when a conductor moves through a magnetic field, creating a voltage, or in other words, an electromotive force is developed across the ends of the conductor. It is one of the fundamental principles of electromagnetic induction. Motional EMF is the principle behind the operation of many electrical devices we rely on, including generators and alternators. They convert mechanical energy into electric energy by moving conductors through magnetic fields. The Hall effect is another example of how charged particles in a conductor responds to a magnetic field. It results in the generation of a transverse voltage, Hall voltage, when a current carrying conductor is placed in a magnetic field perpendicular to the current direction. The fundamental laws and phenomena we offers intriguing insight into the behavior of charged particles at the quantum level and falls in the fascinating intersection of classical electromagnetism and quantum physics. Thank you for joining in this exploration of motional EMF in 3D graphics. You can visit the 3D interactive visualization of motional EMF at effectual.github.io and effectual.com. If you found this video informative, don't forget to like and subscribe for more educational content. Thank you.